Hello everyone and welcome to another video in my channel. In this video, I'm giving the white root of 4 to power x is equal to 32 times the x root of 8 to power y. This is a radical equation, and we see that we have two unknown variables in one equation. Normally, we are supposed to be given another equation, making it two different equations so we can solve them simultaneously. So people run away from problems like this, particularly secondary school students. But how are we going to solve this problem? That is what this video is about. Now, the step-by-step approach that I am going to apply here is already familiar with many secondary school or college students. But before I proceed, I would like you to do me a favor. Please like this video, subscribe to my channel if you haven't done so, and also share this video to your loved ones. There are many other interesting videos in this channel that I would like you to check out. So please do try and check them out. I would like you to also pause this video and try this question, then come back and then see if you get the answer. Then I would like you to comment on which method you use in solving this problem. So I was saying that many students are familiar with the process or the steps I'm going to use in solving this problem. And it is all about application of the properties of indices. Now, in this first part, and even in the second part, we can apply this property, that is, the bit root of a to power c is equal to a to power c over b. So the radical, which is the power of this number, can be expressed like this. So let us write this now in this form. So it becomes 4 to power x over y is equal to 32 times, we'll also apply this property here, 8 raised to power y over x. Fortunately, the numbers can be written in base 2. So we can write this as 2 raised to power 2 times x over y is equal to 32 is 2 raised to power 5 times 8 is 2 raised to power 3 times y over x as the power. Now we need to apply another property of indices, and that is the addition property or addition law of indices. So if I have a raised to power b times a raised to power c, I can write it as a raised to power b plus c. So it simply means that since the base is the same, I can add the powers together because the base are being multiplied. So it becomes 2 raised to power 2x over y is equal to 2 raised to power 3y over x plus 5. I choose to write this lastly because addition and even multiplication are commutative operations. Now, since the bases are the same, we can cancel them out and then work with the powers. 2 times x over y is equal to 3y over x plus 5. Let's write this as a single fraction. The LCM is x. X divided by x is 1. 1 times 3y is 3y plus x divided by 1 is x times 5 is 5x. So we have 2x over y is equal to 3y plus 5x all over x. We can now cross multiply. And when we do that, we have 2x squared is equal to y times 3y plus 5x, which is 3y squared plus 5xy. So let us move all the unknown to one side. So we'll move this and this to this other side. 2x squared minus 5xy, then minus 3y squared. I can factorize this. So it becomes 2x squared minus 6xy plus xy minus 3y squared. Now let's put them in brackets. In the first bracket, 2x is common. Let us bring it out and divide the bracket by that term we brought out, minus 6xy over 2x. Then close brackets. In the second bracket, y is common. Let's bring it out Then divide the bracket with y, 3y squared over y. Now, this will cancel this and this, and this will cancel this. 2 in 6 is 3. So you have 2x times x minus 3y plus this and this will cancel, giving us y times x minus this and this will cancel, 3y. So we see the brackets are the same. We can take one, x minus 3y, and put this in another bracket, plus y. Very good. Let's remember it is equal to 0. Yes, this is equal to 0. This is equal to 0. Let us remember that it's an equation. So we can equate each bracket to 0, or 2x plus y is equal to 0. And so x is equal to 3y, or 2x is equal to minus y. If I divide both sides by y here, I have x over y is equal to 3 over 1. Or divide both sides by y here, and then by 2, I have x over y is equal to minus 1 over 2. Now, how can we get the solutions? Let's remember that since we have one equation and two unknown variables, we are dealing with Diophantine equations, and normally integer values are being solved for in Diophantine equations. So that means that x is equal to 3 and y is equal to 1. Or in this case, x is equal to minus 1 and then y is equal to 2. Or we can write x is equal to 1, then y is equal to minus 2. These are the solutions to the equation. Now, if we put in 3 for x and 1 for y, we are going to get a balanced equation. Let us try it here. So we have 4 to power x. X is 3 over 1, which is y, is equal to 32 times 8, and y is 1 and x is 3. So this is 2 raised to power 6 is equal to 2 raised to power 5 times 2 raised to power 1. 2 raised to power 6 is equal to 2 raised to power 6. We see we have a balanced equation. If we try the same thing for this pair of solution, which is minus 1 for x and 2 for y, or 1 for x and minus 2 for y, we will get a balanced equation.